Welcome to Lecture 6, Part 2. If you haven't watched Part 1 and created the model with Nimitz and modified the model as described there, I'm going to ask that you stop and go do that first. Otherwise, I'm going to assume that you've modified the Nimitz model in the way that I described there. Okay, so now we're going to talk about what's called a branching rule, and this is where having these connectors is really important. So if you don't have the connectors yet in your model, then you should really go ahead and get them, and send me an email if if you have any problems putting those into your model. Okay, so we're going to talk about another kind of modeling thing. This is called branching by probability. This is where in the simulation you model you have, right, so far we've really only talked about the idea that when arrivals come, they go through a straight line. And of course, that's not true for most systems. Most systems have more complications than that. So today we're going to talk about, well, what happens if they can go to one of two different places? And the self-service option at Nimitz Coffee Bar is really a good example of this. So let's assume that we want to model the idea that about 40% of the students go through the self-service option. Okay. So, and when they do so, we want to also model the idea that it takes 40 seconds to fill their cup, distributed exponentially. Okay, so a service time of which is distributed exponentially with a mean of 40. So what do we need to do? We're going to need to add a second server for the self-service process, and we need to implement a branching at the cashier. Okay, so we get our self-service. We drag another server over. We label it self-service, and we give it, as we've done before, a random exponential with 40 and make sure that's seconds. So you have to change that. Remember, this is on the far right, and this is after you've dragged that object from the left-hand menu out onto the screen. Okay, so we put it there. We put connectors here and here so that it's in the right part of the network. And we want to, the default setting for these connectors have properties as well. They're going to send then entities to the self-service and barista in equal proportions. Okay, so how do we see that? Well, what happens is if you select the connector and you look in the far right at the properties menu, you'll see the selection weight is 1. And if you collect the connector going down to the barista, you'll see that the selection weight is also 1. Okay, so those both have equal selection weights, and so what happens is if you were to run this, Simio would generate random numbers, and half the time, probabilistically speaking, it would send it to the barista and half the time to the self-service. So we want to change that. So what do? We just change the weights. We change this weight so it has a weight of 40, and this has a weight of 60. And so what happens is that Simio, I think, I don't know if you can infer this, but you should be able to infer that what it does is it adds up those two numbers. That's the denominator. The numerator is each of these weights, and that's the probability it uses to direct arrivals. Okay. So now you can run your model, and when you do so, you can again go to the results menu and see what happened. You scroll down. I have these are actually two screenshots. One is looking at the server for the barista. We see that a number 396 entered and 396 exited. And over here we see that we had 261 entered and 261 exited the self-service. And if you think about that, well, what is that? That's roughly, this is 396 divided by, 261 plus 396, okay, which is equal to 396 over 7, 657. And you can see that is roughly 60% of the total customers that entered indeed went over to and it's very roughly speaking, it's probably not exact. It's not exactly 60%, of course, but it's pretty close to 60% of the customers that enter the system went over there. So we can see that it's working. Okay, this is sort of an important thing to do. Whenever you modify your model, you should figure out some way to validate whatever you did to it is correct. And so by looking at these, in the same way that we did this with the input arrivals, we look at the results right after a change and we say, okay, did that work the way we expected it to work?